In this next topic, we're going to continue looking at compound interest, but this time we're going to be looking at different compounding periods. So, in all the previous examples we did with compound interest, they were compounding it annually, but now we're going to be looking at compounding the interest more than once per year. So, either semi annually, quarterly, monthly, weekly, or daily. So, we'll get to that in 1 second, but first let's try these at the top because we're going to have to know how to work with exponents in our calculators. So if we're doing 3 times 4 to the power of 2, we would begin by just doing this 4 to the power of 2 first. So we have to start with the exponent if we're following BEDMAS, and that exponent's only attached to the 4. So we're going to do 4 to the power of 2 in our calculator, which is 16, and then we would do 3 times 16, which is 48. Now, like I said in the previous topic, if you have a scientific calculator, you might be able to plug this entire thing in all at once and get 48 as your answer, as long as you put it in exactly how it's written here with the brackets and everything. So again, we're going to do the next one. So I'm going to follow BEDMAS, and I'm going to do 3.2 to the power of 2 first, which is 10.24, and then we're going to multiply that times 6. So the final answer would be 61.44. For number 3, if we follow BEDMAS, we would do everything in the brackets first. So we would do 1 plus 0.5, which is 1.5, and that's going to be to the power of 3. And then that 2 on the outside is still there. So 2 times 1.5 to the power of 3. So then I would do 1.5 to the power of 3 in my calculator first, and you would get 3.375, and that's going to be times 2. So then your final answer would be 2 times 3.375, which is 6.75. And then finally, for the last one, we have 400 times 1 plus 0.8 divided by 2, because remember this line here means divided by, and then all of that to the power of 2. So then how I would do this question is I would start in the brackets, and I would follow BEDMAS within the brackets. So in the brackets, we have addition and we also have division. So I would start by doing 0.8 divided by 2 first. So I would do 0.8 divided by 2, which is 0.4. So instead of all this here, we would have 0.4, and then 1 plus 0.4 would be 1.4. So we have 1.4 in the brackets, and then to the power of 2, and that 400 is on the outside there. So then if we do 1.4 to the power of 2, we get 1.96, and we're going to multiply that times 400. So if we multiply that by 400, we would get 784 as the final answer. So now let's look at compound interest with different compounding periods. So interest rates are usually expressed as a rate for 1 year. However, interest can be compounded in different ways. The number of compounding periods depends on the type of investment and the institution. So this chart shows some of the compounding periods. So it'll tell us in the word problems how many times it is going to be compounded. And in all the ones we've looked at before this, it said annually. But now in these questions, it's going to give us different compounding periods. So if it says semi-annually, that means it's compounded twice per year or 2 times per year. Like a semicircle, that's half a circle, so it takes 2 of them to make a full circle. If it's quarterly, a quarter is a fourth of a year, so that means it would be compounded 4 times in a year. If it's monthly, we'll think about how many months there would be in a year. That would be 12, so that would be compounded 12 times a year. Weekly would be 52 times a year because there's 52 weeks in a year, and then daily would be 365 times per year that the interest is collected or compounded. So now let's look at this example. Kevin wants to invest the money he earns teaching piano lessons. He found an online bank that has a high interest savings account rate of 1.8% per year. The interest is compounded monthly. So now it's not compounded annually, it's compounded monthly. What is the monthly rate? How often will his money be compounded in 5 years? So for this question, I'm actually going to skip this first one where it says, what is the monthly rate? We're going to skip over that. So that would be this whole first part. You can cross that out. And instead, we'll just skip to number 2. How often will his money be compounded in 5 years? Well, it's compounded monthly, so that means it is compounded 12 times in a year. So I'll put 12 times per year. So now it's asking us, how many times will interest be compounded in 5 years? So if it's compounded 12 times in a year, we're going to multiply that by 5 years. So 12 times 5 is equal to 60. So the interest will be compounded 60 times in 5 years because it's 12 times per year. So now if we're looking at the next example, Cheryl manages a high-rise building in Vancouver. She invested $40,000 from this year's condo fees for a reserve fund. She invested $20,000 in an account that pays 1.8% per year, compounded semi-annually, and she invested $20,000 in a account that pays 1.8% per year, compounded daily. So there's a little bit of a difference here. We have two different compounding periods. One's semi-annually and one is daily. How does the interest earned on each investment compare after 3 years? So the investment's the same for both of them. The interest rate is same for both of them, but one's compounded semi-annually meaning twice a year. And then one is compounded daily, which is 365 times a year. So let's look at our solution. What is the value of the investment with semi-annual compounding? So we're starting with this first one, and we'll do it all, how about in pink? So we have the formula that we used last topic. So the principal amount that we're dealing with this time is $20,000. So we'll write P here, 20,000. Now the interest rate is 1.8% per year. So that's why they put this decimal. That's the 1.8%. But now we're going to divide that by the amount of compounding periods in a year. So this one we're doing semi-annually, 2 per year. So we're going to take the amount of times it's compounded a year and we're going to put it right here and right here. So we're going to divide by it inside the brackets, and then on the outside of the brackets with the power, we're actually going to multiply it to that n value. And now remember, n is the amount of times we compound in those 3 years. So if we're compounding the interest twice a year for 3 years, we will end up compounding it 6 times. And that's why we do this whole calculation up here, 2 times 3, because we're compounding it twice a year for 3 years. So that's going to equal 6 times. So that's why eventually our n is going to become 6 in the next step. So now let's continue with this. We're going to solve everything in the brackets first. So we're going to follow BEDMAS. So 1 plus 0.018 divided by 2. So remember, start with that 0.018 divided by 2. Plug that in your calculator. And then you're going to add that to 1. So 0.08 divided by 2 is 0.009. And then we're going to add 1 to it. So we're going to have 1.009. And then let's multiply these two numbers in the powers while we're at it. So 2 times 3, that's where we get our 6 that we were talking about. So n is 6. That's how many times we're compounding it in those 3 years or collecting the interest. And then the 20,000 on the outside of the brackets will just stay the same. So in your calculator, you're going to do 1.009 to the power of 6, and then you're going to multiply that times $20,000. And in the end, you should get $21,104.59. So the value of the investment with semi-annual compounding will be $21,104.59 after 3 years. So now we're going to do the exact same calculations, but this time we are going to compound it daily. So remember, daily compounding would mean 365 times per year. So not 2 this time, 365. So our principal amount's going to stay the same, which is $20,000. Then we have 1 plus the rate, which is 0.018 or 1.8%, stays the same. But this time we're going to divide by 365. And then to find the end value, or the amount of times we compound it, we take the amount of times per year we compound it, which this time is 365, and we're going to multiply it by the amount of years. So again, we're dealing with 3 years just like last time. So that's why we're multiplying that by 3. So then let's continue the formula. So start with inside the brackets first. So you're going to do 0.018 divided by 365, and then you're going to add 1 to it. So that final answer should be inside the brackets 1.0000493, and then the decimal will continue going on. And then let's also multiply these two together while we're at it. So 365 times 3 is 1,095. And then that 20,000 we haven't touched yet. So again, we're going to do a similar step. We're going to do 1.0000493 to the power of 1,095. So remember, you're looking for that button that looks something like that on your calculator, or maybe an empty box or something of the sort. Message me if you can't find it and I can help you. So you're going to do 1.0000493 to the power of 1,095. And then we're going to multiply that times 20,000. And in the end, you should get $21,109.66. So the value of the investment with daily compounding would be $21,109.66 after 3 years. So how does the interest earned on each investment compare? So let's take the bigger amount we had, which was the 21,109. That's the one we just calculated, and 66 cents. And let's subtract that smaller number we got from the first part. Because if you compare these two, and here I'll highlight them so you can see, the pink one was a smaller amount, but just slightly. So let's calculate how much it was smaller. So if we subtract those two numbers, in the end, we will get $5.07. So the investment that had more compounding periods earned $5.07 more interest over the same period of time. So by compounding it or collecting that interest more every year, we earned an extra $5, which isn't that much, but it is a little bit more.